Welcome back. So we are now looking at part of a legacy functional skills maths paper. So again, what we see here is a sequence of questions that are going to follow following a similar theme. Here we have football training, and we have a sort of literal diagram to help us answer the question. Being Mikhail plays football. He's preparing for fitness tests. The first test is to run 100 meters as quickly as possible. And we're given the measurement of one side of the pitch, 105 meters, and the measurement the other side, which is 68 meters. Diagram not drawn. I plain see that one. Michael runs along the perimeter of this pitch 4 times. Does Michael run a total distance of 1600 meters? Use the box below to show clearly get your answer. Essentially what we're doing here at the moment is perimeter. Now perimeter is different to area. Area, you times length by width to get your meters squared. Perimeter, you're finding out the distance around the outside of something. So what we're doing is we're adding up the two sides of 68 meters and the two sides of 105 meters. All sides of the pitch, which we can see here, which I've done, are clearly demonstrated, physically writing out the sum. So we get 346. Okay, I have a deliberate error here. I've just noticed that I haven't actually put 346 meters or m. However, for the purpose of this, we'll carry on. 346 meters times 4 runs. Pitch is 1,384 meters. Therefore, our answer will actually be no, because Michael's only run 1,383 meters. However, the key point is here, despite my earlier error on here, I have actually answered the question, final answer in meters, so that will be sufficient. And again, we have the distance, but we also have to give the verbal answer or a written answer, so to speak, saying is he right, is he wrong? 1,600 meters isn't it 1,600 meters? And the answer is no, it's not 1,600 meters. Okay. Again, throughout all this, if you want to take pictures of the screens, feel free to do so because these are useful tools later on. So what we have here is Mikhail now does a sprint and turn test to measure his fitness level. He does this 5 times. His results are in seconds. We have those all written down. 25.1, 24.3, 26.8, 27.6, and 29.2. Mikhail must have a mean time of less than 27 seconds to pass his test. We don't have to show them his past tests. Okay, and again, we need to be showing our workings out. So mean average, straight away, is add everything up and divide by the number of results. So we've actually got 5 results out here. So we can see I've added those all up, which comes out at 133 seconds. I then take the 133 seconds, divide it by 5, which gives us a total of mean average of 26.6 seconds. So our answer is yes, at 20.6 seconds. Again, I'm saying a sequential logical process going through, showing how I've arrived at my answer, which is what I ultimately get marked on this test realistically. Again, we have one of the classics. We just check our working to make sure what we've actually said is correct. So we just have reverse calculation. So essentially, again, I'm just reversing everything that's there. So the division becomes multiplication, and addition all becomes subtraction, until we get to our final answer of 0. Moving on. So we're following the same theme of Mikhail. Looking back at the previous question, this time we need to show something pictorially. So one of the ways we can do that is with a graph. So Mikhail wants to draw a graph to show the times of the 5 tests. So we have exactly the same times as we did in the previous question. And we just need to draw the graph. So it's simply a matter of using the information given and labeling the information the graph is showing. We've already been given a head start for the left-hand side because 2324 has already been put in for us. There's a good indication of what we've got to put up that side, which is going to be the time in seconds. Also making sure that you do clearly label time as seconds, so it doesn't get confused with minutes, hours, and so forth. Down the bottom, we have tests A, B, C, D, and E, which again is clearly labelled, so again is showing us the information that we're going to be putting on. We've added our scaling, side depicted in the arrows, which works quite very well because it's going to be division of 10, which goes against which works with the time in seconds. Again, by taking the 23, 24 and 25, 26, 27, 28, we're just following sequentially. We've actually got our answer there, so half it's been answered for us. It's then just a matter of raising the bars up to represent the times. Why do we use graphs? Well, graphs, as I said, is a very useful way of pictorially depicting information. It's quick and easy. People get a snapshot. It's easy and reason lots of figures. So again, if we're thinking about the workplace, graphs can be used to indicate sales. They can be used to indicate attendance. They can be used to show how much of something is being used and whether it needs to be ordered more frequently. So a graph has many, many different versions or very different ways we can use it and advantages. Next question, you automatically probably want to panic a bit because you can see lots of flow charts going on and wondering what's happening here. So let's just read it through. Carl wants to know how fit he is. He measures his heart rate in beats per minute, BPM, in brackets. Mikhail uses this rule to work out his fitness value. So we have a flow chart. Maximum heart rate, BPM, multiplied by 15, divide by resting heart rate, and a fitness value. Mikhail has a maximum heart rate of 192 beats per minute, resting heart rate of 50 beats per minute. A footballer should have a fitness value greater than 54. Does Mikhail have this? Okay, so he's automatically thinking, how am I going to work this out? Well, don't panic. If you look, the method is shown. You just need to follow the information you're given, which is carefully reading the question, and the question will answer itself. So the maximum heart rate is 92 beats per minute. We'll multiply that 15. If you look, I'm following the flow chart on the left. We divide that by the resting heartbeat, which is 50 beats per minute, which equals our fitness value, which is 57.6. So we can see the question just follows the logical pattern through, which means the answer is yes, and there's a fitness value of 57.6. So again, when you get a question like that, take a step back, relax, and you can sometimes find the information presents itself ready for you. This is what I classify as a classic functional skills question. It's giving you essentially a problem to solve. Now, many people, I understand the reasons why, because I used to be the same myself, are frightened of maths. It's probably the way you've been taught in school, and it puts fear into us. The way I've overcome that fear over the years is actually to learn that maths is about solving a problem. And you solve problems every day in your everyday life. And you actually use maths at times so you can do that, because even down to how long it's going to take you to work, how long it's going to get you a certain task, how much is something going to cost. You use maths, but you don't realise it. Looking at this question here, this is problem solving. The first football match of the season is on Saturday. The match will start at 5:30 p.m. The match has a playing time of 1.5 hours. There is also a 15-minute break. After the match, Mikhail will do a cool-down exercise of 10 minutes, have a shower and change 20 minutes, drive home 25 minutes. Mikhail wants to get home by 8 p.m. Will he do so? This evening's cliffhanger if we think about it on the television. So, first of all, nice rules. Remember what I said about everything is the same unit of measurement earlier on, or in the previous video. Remember, 60 minutes and an hour. So, let's look. How much time is there between 5:30 and 8 p.m.? Well, there are 2 hours and 30 minutes. We know an hour is 60 minutes, so there's 2 hours here, so there's 2 lots of 60, plus the 30 minutes, which gives us 150 minutes in total. 2 hours, 30 minutes between 5:30 p.m. and 8 p.m. The match playing time is 1.5 hours, so that's 60 minutes plus 30 minutes. That gives us 90. All we read this question now is just literally add everything up and follow the times that you've been given and the times that you've worked out. So we have 90 minutes plus 15 minutes plus 10 minutes plus 20 minutes plus 25 minutes. That gives us 160 minutes in total. We already know from earlier in the question there are only 150 minutes between 5:30 p.m. and 8 p.m. Therefore, our answer will be no. Mikhail will not arrive home by 8 p.m.